All right, guys. So today in class we did a discovery where you learned a little bit more about finding the solutions of a quadratic. And this is just going to recap everything that you should have learned in class. So sometimes we need to find the x-intercepts of a quadratic. And another word for this is called the solutions. And these are the places on the graph where y equals 0. So they're on the x-axis when y equals 0. And we learned about this thing called the zero product property. If the product of two or more numbers is 0, then one of them must have been 0, or both. So if x times y equals 0, and it asks to solve, it means that either x equals 0 or y equals 0. And those are your two solutions. When x times x plus 2 equals 0, that means that either x equals 0 or x plus 2 equals 0. Now, this one is a solution. This one you actually have to solve by minusing the 2 over. Oh my gosh, minusing. I meant subtracting. And you end up getting x is negative 2. Okay, so you just solve it if it's solvable. And then this one means that either x minus 5 must equal 0 or x plus 8 must equal 0. And this one we have to solve both. If we add the 5 over, we get x either equals 5, or if we subtract the 8 over, x equals negative 8. So those are your two solutions. Okay, it's called the zero product property. It only works when it's 0. So don't try to do it if it's not 0. Okay, so now let's give you an actual equation of a parabola, so a quadratic equation, and you're going to solve by factoring. Okay, so number 1, if it has 3 terms and it's equal to 0, do you guys remember how to factor a trinomial using the box method? Okay, so the first term goes here, the last term goes here, and then we make an MA table, and we have to find the two numbers that add to 4 and multiply to 1 times negative 5. Okay, so what are the numbers? What are the numbers that multiply to negative 5 but add to 4? And that's 5 and negative 1. And don't forget they both get x's. And then you plug them in here and here. Okay, and then we do GCF. The GCF here is 5. The GCF here is 1x. The GCF here is 1x, and the GCF here is just a 1. Okay, so let's write our answers. This is now x plus 5, and this is now x plus 1. Okay, now we're not done yet. We have to actually solve it. So now use that zero property where either x plus 5 must equal 0 or x plus 1 must equal 0. And then if you solve both of these, if you subtract the 5 over, then x is negative 5. If you subtract the 1 over, then x equals negative 1. So these are our x-intercepts, or our solutions. Okay, number 2. Now, number 2 is not a trinomial. All we can do on number 2 is take out the GCF. And what is the GCF of these two terms? They both divide by 1x. Okay, so let's actually divide them both by 1x. 2x squared divided by 1x is 2x. And then plus 3x divided by x is just 3. So remember factoring out the GCF. And now, let's use our 0 property. Either x equals 0 or 2x plus 3 equals 0. And then this one's already solved. This one you have to actually solve by subtracting the 3. We get 2x equals negative 3, and then dividing by 2. So x equals negative 3 halves. Those are our two solutions. Okay, so factoring is a great way to solve quadratics. All right, now let's put it all together on a graph. And these are going to be a little bit of work here. All right, so number 3, does it open up or down? And you would say, well, the leading A term is positive, so it opens up. There's a formula for the vertex. If you remember, it's negative B divided by 2 times A. So in this problem, it's negative 7 over 2 times the secret 1. And if you guys type that in the calculator and get it as a decimal, it's negative 7 halves, which is actually negative 3.5. And I like decimals better. I'm going to do that, negative 3.5. Now we have to plug it back in to see the k, right? That's just the h. Let's find the k. So now we're going to plug in negative 3.5 into all of the x's. So parentheses, negative 3.5 squared plus 7 times 3.5. Oh, it's negative 3.5. Plus 6. All right, hit enter, and there you go, negative 6.25. That's the vertex. It's not always nice. The line of symmetry is always x equals whatever the h was. So negative 3.5. The y-intercept, remember you plug in 0 for x. So 0 squared plus 7 times 0 plus 6, or if you know the shortcut, it's just c. Okay, so 6. And then now find the zeros, which are the x-intercepts, which are the solutions. So for this one, it's a trinomial. So we do the MA box. Okay, so x squared here, 6 here, and then we got to find two numbers that multiply to 1 times 6, which is 6, but adds to 7. And that ends up being 6 and 1. So we put 6x and 1x. Okay, and then we GCF. GCF here is 6. GCF here is 1x. GCF here is 1x. And GCF here is 1. Okay, so when we write it, it's x plus 6 times x plus 1 equals 0. And now we want to solve them. So we use our 0 property. When either x plus 6 equals 0 or x plus 1 equals 0. And then if you solve those, this one ends up being subtracted, so it's negative 6. And this one ends up being subtracted over, so it's negative 1. All right, so our zeros are at negative 6 and negative 1. Oh my gosh, okay, let's plot all these points and let's see our parabola. So vertex at negative 3.5, comma negative 6.25 is like about here. We have our line of symmetry right down through the vertex. We have a y-intercept at 6, which means there's a free point on the other side of the line of symmetry. And then we have our zeros, or x-intercepts, at -6 and at -1. All right, so now we're at 5 points make a parabola. So if you connect the dots, these are the 5 key points of a parabola. All right, great job, guys. I'm going to stop here, and then if we want to talk about this one tomorrow, we can. Thanks for watching. Long one today.